Hello, everyone. Welcome back. So we will start today with Zaven Navoyan, who is the director of AI and machine learning at Intent.ai, and he will be telling us about AI-generated music, which we heard at the opening of the WCIT concert. The floor is yours, Zaven.
Hello, everyone. Thank you, Antonik, for introduction. In October 2019, a World Congress of Information Technologies took place in Yerevan, where people all around the world gathered to participate in this event. So one day before that event, another event, the opening ceremony, was took place in the Republic Square of Yerevan. During that event, a big concert, we hear a big concert where the symphonic orchestra comprising of musicians from 15 countries performed approximately 2-hour program of classical music. During that performance, the orchestra performed also 2 compositions generated by AI. So the first one was the WCIT hymn. The model which generates the hymn was trained on hymns of 15 countries, where the WCIT conference took place in the past. And the second composition that they played was so-called AI Sharakan. The composition, the model which generates this composition was trained on the Armenian Sharakans. Armenian Sharakans is a medieval chorals which is used to play during liturgies or church events. So the second composition was generated in real time online during the concert on the stage. So the musicians, they received the scores of the new generated compositions seconds before the actual performance. So they have no chance to rehearse that composition, and we even don't know what it will look like. So to my knowledge, this is the first time that such the real-time generated composition is played by symphonic orchestra, and this is a very big risk not only for the technical team but also for the musicians themselves. Okay, so our goal was the first to generate music that should be perceived by audience as Armenian. So the audience will listen and say, yeah, this is Armenian music. So this is the first goal. And the second goal is that the composition should be generated during the concert in real time. But by the way, I forgot to say that when the composition generates, it transmitted through to the iPads of musicians through the Wi-Fi network, and they were playing using that iPad, not printed scores. Okay, so let's talk about difficulties. The first point that I want to mention is that we need to understand the object and formalize the problem. What does it mean? So let's bring an example from the other field, for example, the object detection. In object detection, in object detection. For example, when you have a bunch of pictures and you need to discriminate the pictures that have dogs in them, and from the pictures that have cats, discriminate one from another. So the problem is very easy to define, easy to understand, and of course the solution can be very complex. But unlike this case, in our case, the problem was not so easy to understand and define. So we need to understand what makes Armenian music to sound as Armenian, and what is so-called, how to define so-called Armenian gen in Armenian Sharakans. So this is the main problem. And the second problem is how to learn this so-called Armenian gen from the dataset. So we need to answer that questions during our research. During our research of the existing technologies. And then we did a black box experiment to understand what is actually learning. Okay, so let's talk about what is automatic music generation in general. So the first solution to this apparently high combinatorial problem was proposed by several authors. The first author was Eptioglu in 1988, where he suggested to use rule-based system for extracting the information from 4-part chorals written by Johann Sebastian Bach, and use that information to generate a new chorals. Another attempt was by the Bogzhayev. By the way, he's a professor at Yerevan State Conservatory in 2004. However, these systems have some drawbacks. The most important is that this you need to write down rules. In a Eptioglu case, there was approximately 300 rules that describe the Bach's harmony, and that this needs human expertise and a lot of resource and time to do the task, to complete the task. Besides that, if you want to change something or change the style of the composer of the system, you need to totally rewrite all these rules. So we understand that these approaches is not feasible for us. The next approaches which we found in the literature was the agnostic approaches, so-called, which require no knowledge about the harmony. So they based on a restricted Boltzmann machine and LSTM networks and gated recurrent units. However, the generation is performed from the left to right, so a user cannot interact with the system. It is impossible to do the reharmonization, for instance, which is the essential how the corpus of Bach chorals were composed. So what is reharmonization? Reharmonization in the music is when you have for example, you want to change the part of your composition or some note composition, taking into account its neighbors. So this is the harmonization, and these mentioned approaches do not allow that. So another approach was the music generation using Gibbs sampling, which is proposed by Sakelario in 2015 and 2016, and also for monophonic music, and by Gaetan Hajaras and his colleagues in 2016 for polyphonic music case. So monophonic music is the music where only one line, that is one instrument or one vocalist is playing or singing. In a polyphonic case, the playing instruments, the number of playing instruments are greater than one. So advantage of this approach is that it allows to a user to interact with the system, that is to do reharmonization of any part. Choice of the approach. Our approach is based on the article of the Guide on Hageres, published in 2017. The article was named the Bach steerable model for Bach oral generation. We use also some of its Python code implementations because of the following reason. The authors in their articles train their system on the Bach orals. And in our case, we have Armenian Sharakans, and there is a lot of similarities between Armenian Sharakans and Bach orals. So both are sacred medieval music. Both are four-part chorals. Chorals means when the consisting from four voices are singing together. So the both compositions have homogeneous structure. So this is very important for us, and we will talk about it in our next slides. And only one note can be sung at a given time. So let's little bit talk about the structure of literary music composition. Usually the best structure for a book or story, as well as for musical composition, is 3-act development. Here I found a good graphic from the internet. It's unfortunately it is in Russian, but I put translations, which depicts the development of emotion in time. So there are two curves. The red one is Romeo and Juliet, and the green one is a fairy tale about the red cup. Here we see that, the X is a time, and the Y is a emotion. So in the middle point is a natural emotion, and as the Y point goes high, the emotions become more positive, and when Y point goes down, the emotions tend to be more negative. So here we see that the emotion changes during time, and we from the point of view of the mathematics, we can see that the process is not stationary. So unlike the common used scenarios in medieval music, in a or sacred music, the chorals usually do not evolve in time. So usually no emotions deviation were allowed during composition. The point is that if the composer puts some emotion in the composition for liturgies, it can have some negative consequences for the composer. The composer could be burned by Inquisition on the fire, so this is not a good thing to do. And also the chorus consists of the 4 types of voice, as I said earlier: sopranos, alt, tenor, and basses. So here I'm going to talk a little bit about the article that I've mentioned. This system takes Midi files as an input. The dataset consists of the Midi files. So in the right place, we see the scores of the chorus. Actually, we see here 2 lines, but it is the 4-line choral compressed in the two lines. And here we have the representation of this choral applicable for computer. So here we see the chorals are represented as a couple of VM composed of voice and metadata. Here in the front 4 lines we see the voice. And here we see the metadata comprising of 2 lines. So and also here we see the hold symbol. Here is the hold symbol displayed as underscore, which means that the previous the note which is played on the previous timestamp should be continue playing at the next timestamp. So we can consider this underscore as a note. And here the T is the duration of piece in the 16th note. So what is metadata? Usually music sheets conveys more information than only the notes played. So they can contain lyrics, key signature, time signature, beat index, implicit metronome, current key signature, current mode, the fermata symbols. The fermata symbol usually used by in the music when the composer want the soloist to hold the current note longer than it is actually written. In a Bach composition, fermata symbol uses in Bach choral. Sorry, the fermata symbol is used only at the end of the end of the chorals. So the authors of this article marked by fermata symbol the ending of the choral. Here I marked only 2. Sorry, these 2 metadata, the beat index and the fermata symbol by bold, because this is what we use in our implementation. So the metadata consists of the subdivision list S that contains the indexes of the beat in a bar, and fermata list F that indicates if there is a fermata symbol. So the fermata symbol list is a list of Boolean values. Each element in this list represents if there is a fermata symbol set at the current timestamp. So M is a collection of metadata list and metadata lists S and F. So if we go back, here we see the actual V list of 4 lines. This is for sopranos, this is for altos, this is for tenor, and this is for bass. Here is the metadata. Here is metadata, the list of metadata. The first line is the beat index 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And here is the actual the fermata list, which is here all 0, and for the following 4 notes it is set to 1. Here, if we see to the, if we look at the notes in the left, we will see the fermata symbol exists here. So here we mark it by the value of 1. Okay. So what is the formalization of the problem? So-called Armenian gen or Hayugen of Armenian sacred music is about to learn these conditional probability distributions parameterized by theta IT parameter, where I is the number of list of voices, T is the index, T is the time index, and VIT is indicates the note of voice I at the time index T, and the V/IT indicate all variables in V except from the variables VIT. So the probability VIT given all its neighbors, metadata, and controlling parameters theta. So Here, because of the homogeneity, because our for us, we assume that are homogeneous, we assume that these parameters and these probabilities do not depend on time, and we take their static values. So the problem is the following: we feed each of these conditional probability distribution on the data by maximizing the likelihood. Due to the weight sharing, this amounts to solve this amount the following form. So we have a 4 equation here. So we have a 4 equation here for each line, and here is the log likelihood of these conditional probabilities, and we need to find these theta parameters, which maximizes this log likelihood. So the aim is to predict the node, knowing the value of its neighboring nodes and metadata. So to solve these 4 equations, authors define the following model of neural networks. So here we see so for accurate prediction, and in order to take into account the aspect of the data, each classifier is modeled using 4 neural networks, 2 deep recurrent neural networks here, 2 deep recurrent neural networks, one summing up past information. This is one for summing up the information coming from left to right, and another one summing up information coming from the right to the left. That is the information coming from the future. And then there is a third neural network which is non-recurrent. This is to model the nodes that are playing at the same time. Therefore, at the same times, it can be played 4 nodes as we have 4 lines in parallel. So the output of these 3 neural networks then merge together and go to input to the 4th neural network. The 4th neural network, then the output of the 4th neural network is the probability. So actually that was a process of the training. So we run this neural network on the data set. On the data set of Midi files, and after training, we have this P1, P2, P4 conditional probability distributions, and then we can start to generate a new composition using pseudo-Gibbs sampling. To do that, we fix the length of the foral L, we fix the metadata, and then we create 4 lists, V1, V2, V3, of empty list of length of L. Then the lists are initialized with the random nodes drawn from the ranges of the corresponding voices. So each voice has each range, which is predefined in the configuration of the of each voice, or each instrument has its range. It is so-called tessitura, which is predefined in the configuration of the program. So after that, there is a iteration from 1 to m. The m is the maximum number of iteration. During each step, we randomly choose the I from between 1 and 4. Then we choose T between 1 and L. And we resample the node, a single node VIT, from the following distribution. And repeat this process m times. After repeating this process, at the end we will have the field list comprising of 4 lines. Actually, this is the final generated composition. The V1, as I said before, is the line of the sopranos. V2 is line of the altos. This V3 is tenors, and V4 basses. So, Bach or computer experiment, which is done by the authors in the article, they take a single line from the original Bach chorals, then they reharmonize using 3 different models. The first one is maximum entropy model, the second one multi-layer perceptron model, and the third one is the actual deep Bach model that we talked in a previous slides. Then they take the 12-second excerpt from this reharmonized composition. Also, they took the original Bach harmonization of this same composition and asked approximately 1,200 users to listen and to vote if this current composition is written by Bach or by computer. So the peoples are divided into the 3 groups. The first, who seldom listen to classical music. The second group, the music lover or musicians. And the third group, the student in music composition or professional musicians. So here we see in the for the first model that the most people voted for the computer. So they think that this composition was written really by computer. The second one is has a better perform. Second model better perform, and the best perform model is the deep Bach. And here the interesting thing is that there is still people approximately from 20 to 25 that hear the Johann Sebastian Bach chorals and they still think that is generated by computer. Even some professionals have mistaken. So the percentage of Bach votes increased as the model complexity increases. Furthermore, the distinction between computer-generated extracts and Bach extracts is more accurate when the level of the musical expertise is higher. Okay, so what we have done, what our team have done. So the whole project took approximately 8 months. The majority of the time we were just doing the black box experiment. We are collecting the data set from various compositions, then train a model, then generate new one and analyze the new one. We repeat this process lot of times to actually understand what it is learning. So this process took the majority of our time. So what we understand, we could be able to answer the 2 very important questions that we will be able to train on a small amount of material. Usually in machine learning, it is common to use as much as data in a data set, but here we understand that the messing up a lot of data was not a good idea. It is better to have a small data, but very carefully chosen data. So, so we understand that compositions must be homogeny. No development in time is allowed. So the compositions in datasets should have the same style. The same musical style. The composition better to be in the same tonality, despite the fact that authors claims the opposite. And we also have been able to answer what actually makes characans recognizable as Armenian music. So Armenian characans have been written in 4 groups of modes, and before the second half of the 19th century, usually the characans was written in a so-called 4th group or harmonic major scale. So here we have a scale. It differs from the ordinary common major scale with the 6th note, which is lowered by a half tone. This is widely used in composition from charakan. But at the second half of the 19th century, starting from Komitas and Nikmaline, they start use another tonalities. So we took data straight from the Nikolai Tashyan book, and if I'm not wrong, we have been able to find approximately 17 charakans, which is not a big number. Then our composers started to increase the data set. Our composers started to write new charakans in the same harmonic major scale, in the same medieval style, and also we have they have reharmonized other charakans written by Komitas, Sikmalans, etc., to become to transpose into the harmonic major scale. So at the end, we have in our data set up to 100 charakans. Besides that, the program itself does the data augmentation by transposing the compositions in half tones to make new compositions, new compositions from the existing ones, and this makes the number. This increases the number of data in the data set actually. So the result. We did an experiment similar to the Bach or computer experiment. We asked our relatives and colleagues to listen to the generated compositions and try to guess the composer. So, and the most common answer we received was, I cannot say who is the composer, but it's something Armenian. And we do the same experiment and the same opinion we got from the professional musicians. Our composers, when analyzing the generated scores, they stated that this is the structure is 100% the Armenian charakans have the same structure. Okay. So another question: can generated music be really very nice? So the answer is yes, it can, but only by chance. The model learns only the underlying structure, that is the harmony and rules. But the model's optimizers do not have a function to optimize the so-called beauty. That means that it doesn't even try. Actually, two compositions with a similar structure can be very differently perceived by human in the terms of beauty. It is very hard to say what affects on human perception of beauty. So it's a very complex thing to understand. So where to listen now? If we have a time, if we have a time, I will we will listen to these two compositions. The first, we're going to listen WCIT hymn, and the second one, we will listen to the real-time generated Sharakan. Frankly speaking, the WCIT hymn is much nicer than the second one, because it was we generated here 200 compositions. Then our composer choose for the best looking ones, and just put them together, and actually that was this is the hymn. So it should be a little bit interesting than the second one. So let me let me stop here my screen sharing, and then I'm gonna to share my YouTube screen, and we can hear the compositions there. Just a moment. Can you see my screen?
Yes, your screen is visible. But the sound is terrible, Zaven.
To the second one, which was generated in real time during the concert. From the video, you will be able to see the iPads that was in front of the musicians. Okay. So this was what I want to present.
Thank you very much. We had some quality issues with the sound. Some parts were not audible well, but most of the music was, and we will post the links to the videos in Slack so that everyone can listen with a better quality. Zaven, do you? Okay, so we have some questions, and I will open from the Q&A chat. Minas Abramian is was asking about the WCIT hymn. Now you are talking about the Sharakan, so you will be also some words on WCIT hymn. I think that was before you talked about WCIT hymn. Yeah. So, okay. And the next question he asks is, how do you measure emotions as scalar values? I think that was when you were talking about the books and the musical composition.
Yes, actually, we don't measure emotions. We can't measure. We even do not understand how the emotions can be formalized or modeled. So we don't do that.
Okay. And a question from Maria Morozova. Thank you for the interesting topic. How long it takes to train the AI to create basic music, the ABC? Do you involve musicians, professionals during the training of AI? How do you measure the success? If the newborn music sounds nice or the music meets the rules and structure of the composition?
Okay, thank you for the question. The actual training takes approximately hours on a server with the GPU on it. The actual generation of the composition takes approximately tens of seconds, so this is not so long. And the second question, do you involve musicians? Yes, of course. Our team involved musicians, composers from the State Symphonic Orchestra of Armenia, and we worked together during the whole project. And they are co-authors of this presentation. You can see their names at the end of the presentation. And also the third question, how do you measure the success if the newborn music sounds nice or the music meets the rules and structure of the composition? Actually, we measure success by when we have if the generated music has the same rules and composition, same rules and structure and harmony as the original Sharakans, then this is our success. We think that we will. That was actually our goal. Yes, and we cannot guarantee that the music will sound nice. As we already talked about that. So is there any other questions?
We have two comments. One is from Vagan Vartanyan. I think he's one of your
Yes.
co-authors. He says in Bach chorals there are usually two fermatas. First, separate the first phrase from the rest of the choral. The last clause is the choral. I think. Yeah, this was posted during your talk. And the next one is from Maria Morozova. Thank you. Next time when you will create an artist AI, I would like to work in your team.
Okay, thank you very much.
Okay, So I have another question. When building AI systems, modern AI system, most of the times we start with sort of high quality, large amount of labeled data, and in the past this was not the case. We read the horror stories of highly qualified radiologists sitting and annotating pictures with hand annotating and creating features from the images sort of by hand. And in this talk, in this work, as far as I understand, the role of the the professional musicians, composers, and people who really understand music, this was huge. And I'd like you to reflect on the contrast between training an image classifier on ImageNet and having professionals working months and months together with data scientists on a project like this.
Okay. The difference between the annotating, for example, the images and working with the compositions is the following. When you work with compositions, you need to have very big expertise on music, and the problem is that usually the data scientists and musicians are very far from each other. I mean, if, for example, in the case of the image recognition, everyone can understand what is image and what is depicted in the image. Then the hearing case, in our cases, the data science usually do not fully understand what actually is what actually is in the composition, how it works, what is harmony. So this is a harmony, is a theory of the music. So this is the first difficulties. And you're right. Yeah, when in this project we work with musicians, and they help. Actually, they do the process of analyzing the composition, and they participated in the process of black box experiments to understand how all that working, what actually learns the system. So we did together with our colleagues.
Would it be fair to say that looking at this amount of highly qualified work, we can sort of say that music generation is still far from getting reasonable results by itself, without specialists, and the amount of work that specialists have to put in sort of reflects on this gap that we have, unlike, let's say, image classification.
Yes, I agree with you, and I will say even further that carpet is not likely to produce a very meaningful compositions that can be compared to the human author. So I think that a lot of work should be done to achieve this state.
Okay, thank you. If there aren't any more questions, so you can raise your hand. This is to all the attendees. If you want to ask a question, I can unmute you. Yeah, since we don't have any further questions, and thank you very much, Zaven.
Thank you.